Too high in this low top, air max, to the max, I'ma push that, yeah. To the top, I'ma take that. From the bottom, I go that. I ain't looking for that love, no. I accept all the hate, yeah. It only make me greater and greater. Moving up like an elevator, yeah. You know, nigga built with vibration. So maybe we can rendezvous later. Feels like a little bit of deja vu. Where I'm already slayed her. Cremate you, then recreate you. Inflate you, now she all add up inflation. Now we sipping on the liquor and we turn. And we looking at a motherfucking blank. Blinking on a motherfucking million. When you cash up, they all wanna feel you. King never been a civilian. Got a bad bitch, looks at a kid. Looks at a kid. No, she don't look familiar. Red out of season. Lights in my spotlight. Real view don't see that. Drop an 80 and a 35. Standing on the edge, ready to jump. Taking risks like I know what I want. I'm still flying in the fly zone. I got up in the air on my own. No red out of season. Lights in my spotlight. Real view don't see that. Drop an 80 and a 35. Standing on the edge, ready to jump. Taking risks like I know what I want. I'm still flying in the fly zone. I got up in the air on my own. Got her dressing for me, she impressive. Left her right when she left her impression. Let you meet you will make her confession. That she like to sip, burn, then wind down with your body. Come and see that coochie. Come and deal that booty. Got me feeling like tuna. No red out of season. Lights in my spotlight. Real view don't see that. Drop an 80 and a 35. Standing on the edge, ready to jump. Taking risks like I know what I want. I'm still flying in no fly zone. I got up in the air on my own.
Generating power using atmospheric electricity. A hexacopter was used to lift one end of a corona motor near the ground. Electricity then flowed through the wire and corona motor, making it turn. In this video, I'm going to explain how it works. Much of the following explanation is adapted from Nobel Prize-winning physicist Richard Feynman's lecture on physics, a section called Electricity in the Atmosphere. For every meter you go up in the air, the voltage increases by around 100 volts, or we could say around 100 volts per yard. We can draw these voltage increases using what are called equipotential lines. Notice that the ground is negative and the sky is positive with respect to each other. Where the air is very conductive. This is the case in fair weather. In stormy weather, like a thunderstorm, things are quite different. And it won't. Hi gang, I previously demonstrated generating power using atmospheric electricity. A hexacopter was used to lift one end of a wire high up into the air. Meanwhile, the other end of the wire was connected to a corona motor near the ground. Electricity then flowed through the wire and corona motor, making it turn. In this video, I'm going to explain how it works. Much of the following explanation is adapted from Nobel Prize-winning physicist Richard Feynman's lecture on physics, a section called Electricity in the Atmosphere. For every meter you go up in the air, the voltage increases by around 100 volts, or we could say around 100 volts per yard. We can draw these voltage increases using what are called equipotential lines. Notice that the ground is negative and the sky is positive with respect to each other. According to Feynman, this extends upward to 50 kilometers, or 31 miles, where the air is very conductive. This is the case in fair weather. In stormy weather, like a thunderstorm, things are quite different, and I won't talk about that here. But if this voltage exists between your head and the ground, why don't you get a shock? The reason is that your body is a good enough electrical conductor that standing on the ground, you're basically a part of the ground. The equipotential lines would look like this. there's still effectively 0 volts between the top of your head and ground. Similar effects happen with trees, buildings, and so on. What about the electric current? A downward electrical current exists and consists of positive ions, molecules or clumps of matter that have a positive charge. These ions are moving slowly toward the ground. The current density from these ions is very small, around 10 microamps, or 10 picoamps, crossing each square meter or yard every second. So in any small area, there's not a lot of power. And that's the explanation about atmospheric electricity adapted from Feynman's lectures. To take advantage of this atmospheric electricity, we electrically connect one end of a wire to the ground and lift the other end up into the air. In our case, we got good results at around 120 meters or 390 feet up. At 100 volts per meter or 100 volts per yard, that's 12,000 volts between that height and the ground. But just as with you standing on the ground, the wire is an electrical conductor, and so is also at ground potential. Looking at the equipotential lines around the wire, that voltage of 12,000 volts exists between some distance away from the wire and the wire. You can see that the equipotential lines are closest together at the top of the wire. This means the attraction is strongest there, and electrons make their way upward in the wire. Let's look more closely at the top of the wire. We'd put 6 sharp points using sewing pins at the top of that wire. But for ease of illustration, I'll draw just one. Notice that because of the sharp shape at the point, the charges are crowded together at that point. Remember also that there are positively charged ions in the air. An electric field exists between the negative charges on the wire and the positive charges in the air. And we can represent that electric field by drawing lines between pairs of opposite charges. Notice that the electric field lines are closer together near the point, meaning the electric field is stronger there. It's strong enough to remove the negative electrons from the sharp point, where they neutralize positive ions. But due to the voltage, there are fresh positive ions moving downward and fresh negative charges coming up from the wire. We now have electricity flowing through the wire. The electric current in that electricity is very weak though. We didn't measure it, but from my experience with electrostatics, I'd estimate it in the low microamps, or more likely even lower. That's not enough to turn an electromagnetic motor, one like you use in everyday life, but it is enough to turn an electrostatic motor, like this corona motor. The corona motor consists of a plastic cylinder surrounded by sharp-edged metal blades. Every second one of those blades is connected to the wire going up into the sky. That means that when the wire starts conducting, those blades are now at whatever voltage the top of the wire is up in the sky, though opposite in polarity, positive. That's why you get a shock when you touch one of those wires. Negative charge is then pulled from the plastic cylinder through a gap between the edge of the blade and the cylinder. That leaves the cylinder with the same charge. And since like charges repel, a repulsion occurs that rotates the cylinder. The next blade is connected to earth ground and becomes negatively charged. And since opposite charges attract, it attracts the charged area of the cylinder. It then neutralizes that charged area by taking electrons from the ground. And that's how atmospheric electricity can power an electrostatic motor like a corona motor. Well, thanks for watching. See my YouTube channel for more interesting videos like this. That includes one with a more detailed demonstration of this atmospheric electricity in action powering the corona motor, another showing how this corona motor was made, and one showing how to generate electricity using a Peltier module. And don't forget to subscribe if you like these videos, or give a thumbs up, share with your social media, or leave a question or comment below. See you in a bit.
These things are going into space. Aw, that's adorable.
Bang, bang. Curtain to drop. equals 8 inches per mile squared. The earliest maps ignored the curvature of the Earth's surface. Both because the shape of the Earth was unknown and because the curvature is not important across the small areas being mapped back then. Or could it be that the Earth is not a spinning ball? Let me explain. Let me make sure I got my guy making sure that the world turns. Let's talk spin before we talk about them curves. Although I like curves, in fact, love curves. From the south, like I'm thick. All right, let's talk about this pendulum, this hanging nothingness. A print of the Foucault pendulum, 1895 year. The original Foucault pendulum does not exist, of course. And the experiment has never been repeated either. I wonder why. I wonder why. I really don't wonder why. Really, nigga? Really, nigga? Really? I mean, I wouldn't wonder why you done hung a goddamn marble in the string. So in 1851, Leon Foucault famously demonstrated the Earth's rotation at the Paris World's Fair, of course, a World's Fair, with a large pendulum known as the Foucault pendulum, captivating scientists and the public alike. I'm calling cat. Damn, hanging, spinning ball, because the Earth would turn. Museums that maintain continuous Foucault pendulum motion commonly rely on electromagnets or related magnet drive mechanisms, mechanics, baby, it's all mechanics, to compensate for both frictional damping and environmental. Yeah, about that first, I'm gonna have to go back to it. So you think you live on the spinning ball, huh? Foucault pendulum is an illusion made for fast traction only. Really? Really, nigga? Really, nigga? so, so this is what you're doing. This is what you've been out here doing all day. Boy, get your silly ass off that goddamn spinning ball. Yeah. Yeah. Which one are you on? Which side of the earth you on? Huh? Huh? Which one you on? Which building you in? Where angle you at? Huh? You top, bottom, top? Huh? What is it? Which road you on? Which? Wait. Spinning ball. Slow down. Slow down. Which side you on? Which side? Which side of town you on? Huh? The bottom, top, left, right? Huh? What? Which side of this ball you on? Huh? Huh? Which plane you in? Huh? Which one of you is flying upside down in these planes? Huh? Who got their seatbelt on tighter? So I can tell you right now, phone home, ET, phone home. This is where you reside, homie. If you live on the motherfucking spinning ball, which ups, what? Wait. Let me not forget about this motherfucking water that's being stuck to it. Oh, wait a minute, splash. So now it's gravity, huh? Holding all that water to that spinning ball, huh? Wait a minute, I'm confused with an R. I'm confused. I need to go back to that slide I missed too. Motherfucker went by quick. I'm on the spinning ball, that's why. Look at here. Is it raining upside down or is it raining upside down? I forgot. Hold up, wait, ain't I spinning? Ain't I? So now it's raining upside down, huh? On the spinning ball, huh? on a spinning motherfucking ball, huh? So it's raining upside down. Play with me one more time. Lie to me one more time. Okay, never mind. Back to the world turns. Hey, my guy, your legs ain't hurt you yet? I'm gonna need this world to keep turning, baby. Money makes the world go around. You making me some money. Keep that motherfucker. If you slow down one time, everybody will perish. Hey, look at here. Huh? Wait. Did I just see something? Who the fuck? Wait. So which way did that rocket go, homie? Hey, he had to be going really fast in that rocket to get the fuck out of there. Because that shit is spinning. Lord, with a T. Okay. These goddamn planes confusing me. How the fuck are you landing on this? How the, wait a minute. Wait. Slow it down. Wait. Hold up. Wait. Wait. Wake up, knuckle, before you get yourself hypnotized. I'm trying to unhypnotize your ass. Wake up. You are a boy, damn it. Huh? Come on. What? Who said something? Boy, ain't no way, boy. Which one of you mofos upside down? Huh? Bang. Huh? Which one of you? Huh? Crazy. Someone's wait. Hold up. Let me see if my cell phone working. It's a gazillion of motherfuckers. So, Pinocchio, just gonna tell an even bigger lie. You ain't gonna even condense it. You just let everything get it. So you done said 20,000 of them bitches floating around Earth. Bring that goddamn swallowed up fucking basketball here one time. I'll dunk on somebody in that. Yeah, ain't no time for wrestling balls. Get your ass out there, goddamn cloud cover. You got some spinning to do. Not on my watch. Not on my watch. Type flights, carry the other world, okay? Crazy son of a gun. Bang.
These things are going to space. That's adorable. Why don't you let me show some things? I might just question your belief in that. First, let me just ask you something. Let's see. Do you even know how fast these space shuttles are supposedly traveling to be able to leave Earth? 17,000 miles per hour, and even faster at 25,000 miles per hour to leave Earth's gravity completely. Do you know how fast that is? Do you know how fast a bullet travels? A bullet speed varies, but it can go up to 3,000 miles per hour. So you're telling me those shuttles are going 8 times faster than a bullet. Have you ever seen them take off? No, seriously. Have you ever watched them take off and then take flight and compare their speed to the clouds? When you get rid of all the noise and you just look at it versus hearing it and seeing the flames, seems suspiciously slow. And remember, they tell us they go 17,000 and up to 25,000 miles per hour. They'll tell you a hypersonic jet speed is defined as anything going Mach 5 or 3,800 miles per hour. And they'll say, well, speeds have been reached of Mach 10 only in unmanned craft like NASA's X-43A.
All right, so it says, is the sun only 4,000 miles high? Oh, here we go.
Now, the thing that sinks the global ship is called crepuscular sun rays. Now, as you can see here, the sun rays are coming out right here to the left at around a 7.2 degree angle. Now, right here in the middle, they're coming straight down. Now, when you get back over here to the right, they're coming back out at a 7.2 degree angle. Now, a little bit of calculation would show that a 7.2 degrees on each side coming up to a perfect triangle puts the sun at about 4,000 miles up into the sky. And all the ancients knew this.
Hell.
Now, I'm going to prove that to you really, really quick. Here I have a piece of cardboard that I have cut the edges out perfectly on the edge of this cardboard. Now, over here, we have a flashlight, which we're going to use as our sun source. Now, let's go over here and turn the light out. Notice that the shadow of the edges of the cardboard are parallel with each other. That would be 93 million miles away. They'd all be parallel with each other. Now, let's watch what happens to the shadows of these edges when I move them in close to the light source.
Oh, hell.
Now, about right here is a 7.2 degree angle. Now, if you don't understand this, apparently you failed science and physics. This right here proves that the sun is only about 4,000 miles up in the air. That's the only possible way to get crepuscular sun rays. And as you can see, when I move the cardboard away, the light on the floor is a perfect triangle leading up to the light source.
Oh,
Make
hell.
that make sense.
See
Every
if you
time
can do it.
explorers try to go deeper in the trench, the footage cuts out, equipment crushes, and the whole mission turns into a mystery vlog. Yet in school,
Oh,
we're shown
Lord.
these bright orange diagrams of layers we've never touched, drilled, or even picked at. And here's the wild part. The stories change depending on which documentary you watch. One says it's molten metal, another says crystal structures, another says swirling magma oceans. Meanwhile, nobody's ever been more than a tiny scratch into the crust. Doesn't
Oh,
that sound
hell.
like guessing dressed up as science? What if the
Probably.
so-called core isn't something we discovered, but something we assume to keep the globe model looking neat and complete? When the deepest drones fail,
Ooh.
you're told pressure issues. But when satellites glitch, it's solar winds. When rockets spin off course, it's navigation anomalies. Notice the pattern. Everything unprovable gets wrapped in fancy terminology. And every time someone asks why we can't explore deeper waters, we get animated models instead of actual footage. If the core is supposedly mapped without touching it, then what does that say about everything else they claim from far away?
Oh, hell. Remember when these people went to... That's what your face is... That. And Jeff Bezos, come on.
Are you Michael Smith? Yeah. Are you aware of there's a rumor on the internet that people Are you Michael Smith? Yeah. Are you aware of there's a rumor on the internet that people are saying?
Yeah, it's not me, obviously. I mean, anybody that looks at my background, looks where I was born, it's not me.
So the gentleman who took this video apparently tracked down Michael Smith to ask him what his thoughts were in regards to the fact that he not only looks like the Challenger astronaut, but has the exact same name.
I mean, it's interesting that the Michael J. Smith that was the astronaut looks something like me when we were younger, but really not.
Yeah, you just sure look alike. It's the same
I
name.
know the facial thing, but that's what we looked like, what, 40 years ago?
Mm-hmm.
Yeah.
Okay.
Yeah.
Well, thank you.
Yeah.
I mean, come on. What are the odds that the three on the top have an identical doppelganger living to this day that has their exact same name? And that these two on the bottom apparently have an identical twin that doesn't have any birth records. And this is apparently live footage of immediately after the Challenger exploded. They went to zoom in on the parents of one of the astronauts and look at their faces. It doesn't really communicate a grief. I mean, you could say in shock, but he's smiling. I mean, what is your interpretation of how their reactions are here?
And we're supposed to believe that three people from one space flight have exact lookalikes that have the same age and same exact names. Mr.
Sir, I'm going to have to. I'm going to have to stop.
Sir, this is a public comment.
I know what it is, sir. I'm very familiar with the public comment.
Will you let me finish for at least
No,
10
sir.
seconds?
You're finished. Thank you.
You just violated the First Amendment.
I didn't violate the First Amendment.
No,
He
he didn't.
violated the
This
rules.
is a limit.
Officer, take him out also.
Well, everyone just calm down. They can leave willingly.
Wow.
No, we're leaving willingly. I mean, you don't have to remove us.
You just made a decision about NASA. Because you're making your decisions based. All right, well, you violated the First Amendment.
Oh, hell. Let's keep going. Proof the moon landing is technically impossible. Make sure you like the video, subscribe for more. Let's... Oh, hell. Let's keep going. Proof the moon landing is technically impossible. Make sure you like the video, subscribe for more. Let's keep going.
Now let's talk about the Van Allen belts. These are massive radiation
yeah.
zones that wrap around Earth like a force field. Scientists today, not conspiracy people, actual working scientists, say that passing through those belts without serious radiation shielding would expose a human being to lethal levels of radiation. So, here's the thing. There's this big question about how the Apollo astronauts were protected from all that radiation out there. Folks have wondered for years just how did they manage it. It's a bit of a mystery, really. The Apollo capsule walls were thin aluminum, not thick, not reinforced, just aluminum. The kind of material you wrap leftovers in, honestly. And NASA says the astronauts
crazy.
passed through those belts not once, but twice, both going and coming back. The astronauts came home looking completely fine. No radiation sickness, no hair loss, no long-term health effects documented from the belt exposure at all. Modern space agencies today, including NASA itself, publicly state that getting humans safely through the Van Allen belts remains one of the biggest unsolved challenges of deep space travel. Read that again.
Unsolved.
Unsolved. In 2024. But they solved it in 1969 with aluminum walls and a tight schedule. The original moon landing tapes, you know, the raw footage from the actual broadcast, were recorded over by NASA, accidentally, the most historic moment in human history. And somebody hit record on top of it. Files gone. Just like that. Question everything.
Did you know astronauts train underwater? NASA uses a giant swimming pool called the Neutral Buoyancy Lab. Astronauts practice spacewalks underwater because it simulates microgravity. They even wear full space. Did you know astronauts train underwater? NASA uses a giant swimming pool called the Neutral Buoyancy Lab. It's 40 feet deep and holds 6.2 million gallons of water. Astronauts practice spacewalks underwater because it simulates microgravity. They even wear full spacesuits while diving. It's like space, but wetter. Crazy, right? Subscribe for more space secrets.
I think we all remember the Challenger explosion that took place in 1986 that tragically took the lives of all 7 astronauts on board. Well, the interesting I think we all remember the Challenger explosion that took place in 1986 that tragically took the lives of all 7 astronauts on board. Well, the interesting thing is, a couple decades later, this thing called the internet came about, and someone allegedly found almost all of those astronauts alive and well, many using the same exact names. We have Challenger astronaut Judith Resnick, and also Judith Resnick, Yale law professor. Michael J. Smith, the pilot of the Challenger astronaut, and also professor at University of Wisconsin, now retired Michael J. Smith. Commander Dick Scobie, who is now president of Cows and Trees. Now, if you'll notice, they all have the exact same faces 30 some odd years later, the same exact name, and they are the same age. Now, to have the same face, the same age, and the same exact name is extremely rare. So rare, I could only find one case in the last 120 years. And we're supposed to believe that 3 people from one space flight have exact lookalikes that have the same age and same exact names. This
Oh, hell, here we go. Y'all like the video, subscribe for more.
Now, why would NASA be frolicking around in Algeria
Oh, hell, here we go. Y'all like the video, subscribe for more.
Now, why would NASA be frolicking around in Algeria, but pretending to be on the planet of
hell?
Go to Mars and take a bunch of videos and pictures and it'd be super, super simple? No.
You think?
They decided to go to Algeria, which coincidentally looks exactly like Mars, and then claim to be on Mars.
Oh, hell.
You know, NASA says that this is a real picture of Mars. But I would argue that that is a CGI image. And the real videos and pictures of Mars reveal to us that Mars is not a giant rock in outer space that we can land on, but it's light and sound resonance in the firmament above.
Oh, snap.
That is energy, light and sound, vibrating at a specific frequency in one of the layers of the firmament. It is not a physical planet that we can land on. And the funny thing is, if you mimic the atmosphere of Mars, which is basically just CO2 and nothing else, you can't have propulsion. He turns the fan on and it won't even blow a feather. So the videos of all of these rovers landing on Mars with a bunch of dust getting kicked up, it's all fake. Unless they went and landed in Algeria, which is probably what they did.
Oh my
what you're
God.
watching is a drone landing in Algeria. But when that guy turned that fan on and the feather actually started moving, that's because he added air back into the chamber. He created the atmosphere of Earth.
When stocks and gold go up together,